Okay, so in this particular problem solving, again, this is a combination of the two conversion, mole to number of particles, or vice versa, number of particles back to mole. So it's important that you have to read the problem carefully so that you will be able to know what type of conversion you're dealing with. So in number 1, you see how many moles are there in 6.55 times 10 to the 25 molecules of water. So you are given the molecules, which is the particles, and you're asked for the mole. So it's number of particles to mole conversion. And then you look at your notes as to how to do that. So if we are having number of particles to moles conversion, that means you have to bear in mind the divide. That is the technique if it's the particles to mole. So we're going to divide. So how will that look like? It's going to be your 6.55 given again will be written first. So 6.55 times 10 to the 25 molecules. And then we're going to multiply it. And because it's divide, so that means the 6.02 times 10 to the 23 will be below. And the unit for that, I will just follow whatever is the unit in the given. So that's going to be molecules in here. And of course, the one on top will always be a 1 mole. And then I close the parenthesis. And then I am going to cancel first the units so that I will be left with a mole. And then I go to the calculator and I'm going to input this one here. So I'm going to input the values here. So I will input 6.55 first. So that's 6.55 times 10 to the 25, and then arrow to the right. Then I press divide now. So I press divide. Then open parenthesis. I have to enclose that to make sure that I get the accurate answer. And I input the Avogadro's number. That is 6.02 times 10 again, times 10 to the n. And then 23. And then arrow to the right, close parenthesis. And now I am ready to press enter. And you will see all the answers in there. But again, we will just pick the first 3 significant digits. So that's 108. But then I have to look at the 4th digit first. If it's 5 up, yes, it is. It's an 8. So the 8, the last 3rd digit here, 8, will have an added number. So the final answer will be 109. So that's going to be 109. And then we will put the unit. Whatever is the remaining unit in our solution, that's going to be the final unit. And then we attach the substance, so that's going to be all. The substance is H2O, so that will be 109 moles. Oh, this one we can put an S because it's more than 1, so we can put moles there to make it plural. So the final answer is 109 moles of water. I'm going to proceed to number 2 so you will know how to answer the rest, okay? So for number 2, this is a little long this time. If there are 5.00 moles of water in a sample, the question is, how many hydrogen and oxygen atoms are there? So we are asked for 2 answers, the number of hydrogen atoms and the number of oxygen atoms. But the first question is, what type of conversion is this? I am given the mole and I'm asked for the atoms. So this is a mole to particles conversion. And in a mole to number of particles conversion, we're going to multiply. Okay, we're going to multiply. And because there is a portion here that you're asked for the number of atoms, that means I have to look at the subscript afterwards. So let's do the calculation now. So we're going to begin with our given again. So that's 5.00 moles of water. We're going to do the regular computation of multiplying. So multiplying is putting the Avogadro's number on top. And then that will be molecules here because this is water. And then that's 1 mole below, 1 mole. And then I am going to start with the hydrogen first. hydrogen atoms, I look at the subscript of hydrogen in H2O, that's 2, so I'm going to multiply it by 2. So this is for hydrogen. Now we're going to look at the calculator. We're going to input everything in the calculator. So that's 5.00 is just 5, times, open parenthesis, your Avogadro's number, 6.02, times 10 to the 23, arrow to the right, and then we close the parentheses, and then times 2, okay? And then we enter, we see all the numbers, and we are given already the 3 significant digits, so all we need to do is copy whatever is there. So that's 6.02, and the exponent, please don't ignore that, that's times 10 to the 24. That's times 10 to the 24. And because this is for hydrogen, because that's times 2, so you're going to say H atoms in H2O. So that's H atoms in H2O. And that is the answer for the hydrogen. Now, we still have oxygen left. So for the oxygen, it's still the same. So 5.00 moles times again your Avogadro's number on top. So 6.02 times 10 to the 23 molecules of water over 1 mole. And then after that, for the oxygen, we look at the subscript of oxygen in H2O, which is none. None means 1. So we're going to multiply it by 1 instead. So it's just basically 5 times your Avogadro's number, because times 1 will give you the same answer. So we input 5, then times, open parenthesis, 6.02 times 10 to the exponent, 23, arrow to the right, we close the parentheses, and equals. So we get also the 3 digits. All we need to do is copy that. So that's 3.01 times 10 to the 24. So oxygen, I'll just put the word oxygen, okay, because the O might confuse with a 0. So oxygen atoms in H2O molecule. And that is the answer for the number of oxygen atoms for number 2. So basically, this classwork will be either this style, the divide style, or the multiply style. So that is what CA9 is all about. Now this time, it's going to be your turn to finish the rest of the problems.